Hello, today you will learn about probabilities and how it affects the chances of an event occurring. You might wonder, why is probabilities important and why do I have to learn it? Well, use probabilities in games, weather forecasts, medical testing, and business planning. Every prediction starts with numbers, outcomes, and logic. Probability measures how likely an event is to occur, and the value ranges from 0 to 1. 0 means the event never happens, and 1 means the event always happens. The basic formula stays the same across all topics. Probability equals the amount of desired or favorable outcomes divided by the total amount of possible outcomes. In this video, you will study three main types of probability: theoretical probability, compound probability, and conditional probability. To understand probability clearly, we'll begin with situations where all outcomes are equally likely. In theoretical probability, you assume every outcome has an equal chance. We always want to keep this formula in mind, which states that the probability of an event occurring is equal to the amount of favorable outcomes divided by the amount of total outcomes. Let's say you were to roll a standard 6-face die numbered 1 to 6, and you want the probability of rolling a 4. The number of favorable outcomes is only 1, which is rolling a 4, and the total amount of possible outcomes is 6. This means that the probability that you roll a 4 in a 6-sided die would be 1 over 6. So if you were to write it, it would look something like this. A deck has 52 cards and there are 4 kings. The number of favorable outcomes in this case would be 4, while the total amount of possible outcomes is 52. So the probability of drawing a king in a standard deck of cards is 4 over 52, which can be simplified to 1 over 13. This means that in the long run, you would average 1 king every 13 draws on average. Let's say you roll a die and you want an even number. Even numbers on the die are 2, 4, and 6. The number of favorable outcomes would be 3 and the total amount of possible outcomes is 6. This means that the probability of rolling an even number on a 6-sided die is 3 over 6, which can be simplified to 1 over 2. So far, we've only looked at one event happening at a time. Now, let's say you have 2 coins or 2 die. What would this affect? Compound probability determines the likelihood of 2 or more events occurring simultaneously. You often use the multiplication rule. If events stay independent, multiply their probabilities. Independent means one event does not change the outcome of the other. The formula used for compound probabilities looks like something like this. This basically means that to find the probability that 2 independent events are going to occur simultaneously, you want to multiply the probability of the first event by the probability of the second event. Each coin toss has 2 outcomes, heads or tails. The probability that you flip a heads is 1 in 2. But if you toss a coin twice and you want heads on both times, you multiply the probability of flipping a head the first time by the probability of flipping the head a second time. It would look like something like this. 1 out of 4 possible outcomes gives 2 heads. You flip a coin and you roll a die. You want a heads and a number greater than 4. We know the chances of you flipping a heads in a coin is 1 in 2. And we know that numbers greater than 4 are 5 and 6. So the chances that you roll a number greater than 4 would be 2 over 6, which can be simplified into 1 over 3. You then multiply the probability of each event occurring, which gives you 1 over 2 times 1 over 3, which gives you 1 over 6. Compound probability also includes OR events. For OR events, you add probabilities. Notice how the formula has changed. This essentially means that the probability of either event A or event B occurring is equal to the probability of event A plus the probability of event B occurring. Let's say you roll a die and you either want a 1 or a 6. The probability that you roll a 1 in a die is 1 in 6. Same goes for rolling a 6. If you add both of these events, since the outcomes do not overlap, it will give you 2 over 6, which then can be simplified into 1 over 3. Until now, we've only talked about independent events, but sometimes one event changes what happens next. Conditional probability measures the chance of an event given that another event already occurred. One outcome changes the sample space, meaning that the outcome of one event changes the probabilities in the second event. This formula can be read as the probability of A given B, and you can find it by dividing the probability of A and B happening together by the probability of B. Let's say a bag contains 3 red balls and 2 blue balls. You pick one ball and do not replace it. You want the probability of picking a red ball second, given that the first ball was red. After removing one red ball, there will be 4 balls in the bag, 2 of them being red. So the probability that you pick a red ball after picking a red ball for the first time and not replacing it would be 2 over 4, which then can be simplified into 1 over 2. Notice how the first event changed the probability of picking a red ball in the second event. A deck has 52 cards and 4 aces. You draw one card and do not replace it. You want the probability that the second card is an ace, given that the first card was an ace. The remaining number of aces in the deck would be 3, and the total amount of remaining cards in the deck would be 51. This means that the probability of drawing an ace after drawing an ace on the first draw and not replacing the card back would be 3 over 51, which then can be simplified into 1 over 17. I have taught you guys about the 3 types of probabilities. Theoretical probability, which uses mathematical outcomes, compound probability, which combines multiple events, and conditional probability, which updates outcomes after one event occurs. You use these ideas when checking weather forecasts, analyzing test results, and even in predicting match outcomes, showing that probability can be used in day-to-day experiences. Thank you for watching.